Hi everyone, it's Math with AUB. Let's get along for the preparation of SAT GRE GMAT with AUB. AUB stands for Asadullah Bullu. Let me make some space for myself. We are starting from 39 instead of 35. We solve this, erase this and get along. Our question number 39 reads as 1 root of the equation x square minus 5x plus k is equal to 0 is 3. If 3 is the root of this equation, where k is a constant, what are the roots of this equation? X square minus 5x minus k. First statement, x is equal to 3 is the root of this equation. One root of the equation x square minus 5x plus k is 3. One root of the equation is x square minus 5x plus k is 3, whereas k is a constant. And then what are the roots of this one? Utilizing this condition, one root is x is equal to 3 of the equation, quadratic equation, x square minus 5 times x plus k is equal to 0. If we plug in x is equal to 3, because one root of this equation is 3. If we plug in the root x is equal to 3, then we are in a position to determine the value of k. Then plug in the value of k here and solve this quadratic equation. Then it is our required result. Plug in x is equal to 3. 3 square minus 5 times 3 plus k is equal to 0. The square of 3 is 9. 3 times 3 is 9. 5 times 3 is 15 plus k is equal to 0. Positive 9 minus 15, it results in negative 6 plus k is equal to 0. Adding both sides 6 are shifting minus 6 from left to right, it will become positive, k is equal to positive 6. So, utilizing the first condition, that is 1 root of the given equation x square minus 5x plus k is 3, we arrived at the value of k, plug in the value of k here and solve this equation. Now x square minus 5x plus minus k, there is minus k is equal to 0. Value of k is 6, we have x square minus 5x minus 6 is equal to 0. Still there is a twist in the tail. 2 3 is 6. 2 and 3, negative 2, negative 3, they result in negative 5, but it is not going to give us the same brackets like this, x square, 3 to the 6. If we broke the middle term like this, minus 3x minus 2x minus 6, then we are going to face a dead end, x common, x minus 3. We take minus 2 common, then it will become x plus 3. Violation of the rule, these two brackets must be identical. So we take another path. 1 times 6 is 6. 1 times 6 is 6. Negative 6 plus 1, it results in negative 5. So we can break this middle term as x square minus 6 times x plus 1 times x minus 6 is equal to 0. Once is the 6, utilizing 1 and 6, we are in a position to determine the to garner, to achieve, to accomplish the middle term. Minus 6x plus 1x. That results in minus 5x. X common. We have x minus 6 plus 1 common. It's x minus 6. We have one bracket. X minus 6. Other is x plus 1 is equal to 0. So one root is x minus 6 is equal to 0. X is equal to 6. And other one is x plus 1 is equal to 0. X is equal to negative 1. X is equal to negative 1. 6 and negative 1. 6 and negative 1. Option number A is the right option. Option number A is the right option in that case. Our right option is 6 and minus 1. We have given one root of the equation with one root. It is also said that factor number that satisfies divides or in Braille literature zeros of the function. Zeros means not x is equal to 0. Zeros means solution of the equation. Solution of the given equation. We have one root of this equation is x is equal to 3. We plug in the value of x is equal to 3 in that. Then we manage the value of k. That's 6. Utilizing the value of k here, plugging in the value of k, 6 here, then finding the roots of this one. We have solved this quadratic equation. We have solved this quadratic equation through middle term breakup. Our quadratic equation is another possibility to solve this one. Moving towards next question, we have. Moving towards next question, that is 35. What is the domain of the function f of x is equal to 9 minus x square? We have given a function f of x is equal to 9 minus x square, and we are asked to find its domain. What must be the inputs of this function? Whenever there is a square root, we have to avoid negative values, overall negative values for square root. We cannot plug in any value of x that results in negative. This quantity results in negative. That quantity results in negative. For example, if I plug in x is equal to 4, it will give me negative 9 minus 16, it's minus 7. We cannot afford negative sign because we are dealing with a real valued function. What about 5? I cannot. What about 6? I cannot. This quantity we need 0 or positive. 9 minus x square must be greater than 0 or equal to 0. This quantity must be positive or 0. We cannot afford negative value because negative values gives us complex roots, complex numbers, and we are dealing with a real valued function. Solving for x, I have taken whatever is inside the square root, it must be greater than or equal to 0. For this, because we can afford 0 is equal to 0 because our overall function is in the numerator. If same quantity is present in the denominator, then we would have avoided this equal to. We have taken 9 minus x square greater than 0. If this quantity is present in the denominator, it is in the numerator, we can afford 0 as well. Solving for x, we have minus x square is greater than or equal to negative 9. Now look, whenever we are going to switch over anything negative, we multiply with anything negative or divide. Sense of inequality changes. If I multiply minus here, it will become x square is less than or equal to 9. Whenever we are going to switch over negative sign, we are dividing by minus 1 or we are multiplying by minus 1. Whenever we are going to divide or multiply anything negative, anything less than 0, the sense of the inequality changes. Whenever we are going to multiply something negative or divide something negative, we have to change the sense of this inequality. Taking the square root, we have x square less than or equal to 9 means square root of 9. To get rid of square, taking the square root, we have x is less than or equal to positive negative 3, or one can introduce modulus here, or this one can be written as minus 3 is less than or equal to x, or x is less than or equal to 3, or one approach is this. We can write this inequality in a swift fashion. Mod x must be less than or equal to 2. Not to look this one a peculiar thing, positive negative 3, you introduce mod here, mod x less than or equal to 3, It is more appropriate to write this step as this, mod x is less than or equal to 3, So this inequality can be written as this one. From minus 3 to 3, we can take all the values. The domain of this function is the interval, closed interval from minus 3 to 3. Closed interval, minus 3 to 3 means negative 3 and 3, they are both inclusive. That is the domain of this function. That is the domain of this function. Whenever you are going to plug any value from this interval, it will give you 0 or positive, 0 or positive, 0 or positive. It cannot result in negative quantity. It cannot result in negative quantity that leads to complex number, that leads to complex result, that leads to imaginary result. Whenever a function having under root, you have to take care of the things. It cannot be negative. It cannot be negative. The lump sum, the overall result in the square root, negative cannot be afforded. Negative cannot be afforded. Negative cannot be afforded. Number one. Number two, if square root is present in the denominator, then you have to drop this equality sign as well. Because we cannot afford 0 in the denominator. We cannot divide with 0. We cannot divide with 0. We cannot divide with 0. So, in that case, our domain is from negative 3 to positive 3. The closed interval from negative 3 to positive 3. The closed interval from negative 3 to positive 3. In case of square root, we hunt down, we sort out the values that gives this square root quantity must be positive. Square root quantity must be 0 or positive. 0 or positive. We cannot afford negative value in square root because we are dealing with the real valued function. Moving towards next question, we have moving towards question number 36, a question based on probability. We are asked to find probability. What is the probability of selecting a number in random out of the range of 1 to 17 inclusive? Inclusive means from 1 to 17. And getting a prime number. Numbers, the total sample space in our case is 1, 2, 3 up to 17. We have to hunt down prime numbers between 1 and 17, from 1 to 17. Here the misconception about 1. 1 is neither prime nor composite. And secondly, 2 is the only even prime. The rest primes are odd. 1 is neither prime nor composite. 2 is only prime number. 2 is only even prime number. The rest prime numbers are odd. Keeping these two facts in mind, the rest is easy. These are our prime numbers from 1 to 17, 2, 3, 5, 7, 11, 13 and 17 itself. How many are these? Count them. 1, 2, 3, 4, 5, 6, 7. Our probability of prime numbers is, in that case, favorable divided by total. Total from 1 to 17 inclusive. Total numbers are 17 and they are 7 prime numbers. 7 over 17. This is our answer in that case. And the probability density function is, the range of probability is from 0 to 1. The minimum value of any probability question is 0. The at most value of the probability question is 1. 0 means we are sure it is not going to occur. 1 means we are sure it is about to occur. 100% occur with guarantee. Otherwise between 0 and 1. Otherwise it is between 0 and 1. That's the probability. Just keep two things in mind. 1 is not a prime. 2 is only even prime. The rest primes are odd. A prime number has exactly two divisors. 1 and itself. Prime number has exactly two divisors, 1 and itself. On the other hand, composite number has at least 3 divisors. Composite number has at least 3 divisors. Composite. Opposite of prime number is composite. Composite number. They have at least 3 divisors. More than 3 is possible. At least 3. A number having 2 divisors exactly is prime. A prime number having 2 divisors, 1 and itself is prime. On the other hand, composite number means It has at least three divisors. It has at least three divisors. It has at least three divisors. Moving towards next question, we have moving towards question number 37. For a polynomial g of x, the value of g of 5 is minus 9. Which of the following statement must be true about g of x? Which of the following statement must be true about g of x? We have g of 5 is equal to negative 9. G of 5 is equal to minus 9. Where g of x is a polynomial. G of x is a polynomial of any degree. What we have? This one means we have plug in the value x is equal to 5. X is equal to 5, or we can write this as x minus 5 is equal to 0, and that is the result. In that case, we say that whenever we have put x is equal to 5 in the function, we have the value negative 9. Whenever we have put the function x is equal to 5 in the function, whenever we put x is equal to 5 in the function, we are getting minus 9. How to translate this into such type of statement? It means that whenever we plug in x is equal to 5, we have remainder negative 9. We have remainder equal to minus 9. Here, 9 is our remainder. Negative 9 is our remainder. If it is 0, then we would have said that x is equal to 5 is the root of this equation. In that case, minus 9 is a non-zero figure. Then we can say that when we divide g of x by x minus 5, we get remainder negative 9. That is the translation of this g of 5 is equal to minus 9 inverse. If g of 5 is equal to 0, then we would have said that x minus 5 is the root of this equation. X minus 5 is the factor of this one. X is equal to 5 is the root of this polynomial. But here is the remainder non-zero quantity. Then we said that when we divide g of x by x minus 5, we get the remainder minus 9. So in that case, our correct option is C. The remainder when g of x is divided by x minus 5 is 9. That is the translation of this statement. G of 5 is equal to minus 9. The function value at x is equal to 5 is minus 9. The function value g of 5 means at x is equal to 5 is minus 9. Then x is equal to 5, shift 5 here. It means that whenever we are going to divide g of x by the linear factor x minus 5, our remainder is minus 9. Means when we divide g of x by x minus 5, the remainder is minus 9. Okay, moving towards next question, we have question number 38. It says that find m. Determine the value of m if the sum of the consecutive integers from minus 16 to m inclusive, means minus 16 and m both are included in the sequence, is 74. Question number 38. We are asked to determine value of m. M is our question mark, and our sequence runs from minus 16 to m, and its sum is 74. And here these are consecutive integers. For consecutive integers, we have two possibilities. Whether we have to run forward or backward. Backward, minus 16, minus 17, minus 18, minus 19, and so on. Forward, minus 16, minus 15, minus 14, minus 13, minus 12, and so on. Look at the sum, look at the sum, look at the sum. Sum is positive quantity. Sum is a positive quantity. Sum is a positive quantity. Means we have to move forward. We have to move forward. We have to add one, positive one in that case. It is like that, minus 16, minus 50, minus 40, up to m. And their sum is 74. Their sum is 74. Now we are asked to what extent of the integer m, to what extent the integer of m, we continue this journey to get the sum 74, to get the sum 74, to get the sum 74. First orthodox method is RA first term is negative 16 and common difference, the difference between minus 15 and 16 is positive 1. The difference between minus 14 and 15 is positive 1. That's our common difference. D is 1. And to what extent? Our m is equal to n. Our m is equal to n. How many terms we have to take in? To what extent we have to take m? Suppose m is equal to r n. M is r n. To what extent we have to run m? Here, applying some formula, Sn is equal to n over 2 times 2a plus n minus 1 times d. That is our sum formula. We are interested in m. We have to find out n. We have to find out n is equal to m. N we are interested to find it. We have given sum. Sum is 74. Taking n as n over 2. Our first term is negative 16 rule, and we are interested in our d is positive 1. Shift 2 here. 2 times 74. Then we have n. 2 times negative 16, negative 32 plus n minus 1. 74 and 74, they are 8. 148. And minus 32 minus 1, it will become n times n minus 33. N minus n 33. Or it will become n square minus 33 and shift 148 here. It will become negative 148 is equal to 0. Factorize 148 to break the middle term or whatever is possible, or apply quadratic. Applying table of 2. Applying table of 2, 3 and 7, and here is 37. So we have factors 2 to the 4 and 37. 4 and 37. If we subtract 4 from 37, we are going to get 33. It is our n square minus 37n plus 4n minus 148 is equal to 0. N common, n minus 37 plus 4 common, we have n minus 37. Solving for positive value, we have n minus 37 times n plus 4 is equal to 0. It will give us n is equal to negative 4. Discarded, n is equal to 37. N is equal to 37 is our wonderful thing. N is equal to 37 is our wonderful. And wait, what we have to do is still, in that case, pass me the duster. Okay. Now, how many terms are there? 37 terms are there. How many terms are there? 37. Starting from negative 16, negative 15, negative 14, and so on up to 0. Then we have to increase. That is positive 1, positive 2, positive 3 up to 16. Now look at this. Negative 16 to positive 16 including 0. Negative 16 to positive 16, they will become 32. If we include 0, they will become 33. How many terms are there? 37. 37. Still we have tried 4 terms more. That is 16, 17, 18, 19, 20. 19, 20. So we have to run this sequence from minus 16 to m. Minus 16 to m means value of m is going to be 20. Value of m is going to be 20. Value of m is going to be 20. It's a simple fact. That is symmetrical. We have symmetrical figures, negative 16 up to 0, then from 1 to 16. from positive 1 to positive 16. If we add them up, they are cancelled out. Negative 16, positive 16, negative 15 and so on. Negative 16, positive 16, they are cancelled out. Include 0, they will become 33. And I have written 4 more terms, 17, 18, 19, 20. If we add this sequence from minus 16 up to 20, we get the sum 74. We get the sum 74. Don't confuse yourself. There are 37 terms in this sequence. 37 terms in this sequence to get the sum 74. But here we are asked to what extent we have to run from minus 16 to m. From minus 16 to m. From minus 16 to m to get the sum 74. There are 37 terms. However, we have run this sequence up to 20. Up to 20. So value of m is 20 in that case. Value of m is 20 in that case. One can verify easily. From minus 16 to positive 16, they are cancelled out. Add them up. 20 plus 19 plus 18 plus 17. They will result in 74. 17 plus 18 plus 19 plus 20. These terms are results in 74. Don't obfuscate the reality. There are 37 terms to get the sum 74. However, in that case, we are asked to find from minus 16 to what integer? Minus 16 to what integer? We have to sum this sequence to get the sum 74. Sum 74. There are 37 terms, but the final term for this sequence from minus 16 to m means 20. M means 20. Value of m is 20. The last term of this sequence in that case is 20 to get the sum 74, but there are 37 terms to get to the sum 74. Students confuse this thing, and value of m is 37. 37 are the total number of terms in that case. We are asked the value of m from minus 16 to what integer, minus 16 to what integer we have to add to get to the sum 74. From minus 16, minus 15, minus 14, minus 13 up to 20. Up to 20. Up to 20. M is equal to 20, up to m is equal to 20, we have to add to get to the sum 74. Total terms are 37 over here, but the value of m is 20. But the value of m is 20. We have to add this sequence from negative 16, negative 15, negative 14 and so on up to 20 to get to the sum 74. Moving towards next question, we have